So let's take a look at the first experimental technique that I wanted to talk about, which is called as the Skill-Lync imaging or shadow graph. So, oh, sorry, I almost forgot this. So this is an experimental technique called as the shadow graph or Skill-Lync imaging. Let me play this once, watch it, and then I'll explain what's going on. So let's take a look at what's going on here. So you have something called as the time here. Look at the time. This is just ridiculous, like 5460 microseconds. So that's really, really fine time resolution, right? Because these processes take place very, very fast. So in 5460 microseconds, your fuel is vaporizing, right? So that's really, really fast. So a shadow graph is a technique that helps you differentiate density values. So here, dark, anything that appears dark is having higher density. So dark is liquid, and anything that's light is going to be having a lower density. And in this case, that is going to be your air, right? So this is going to be your fuel, and that's going to be your air. And shadow graph or a Skill-Lync imaging is a technique that helps you visualize this. Well, why do we do this? Well, in this process, you learn a lot of things. So if I pause this, you first learn something called as the vapor. You learn the spread angle. All right. So this is what you call as the spread angle, which directly affects the atomization capabilities. And then in this case, the reason why the fuel is dark all the way, right? So for example, here the fuel is all the way dark, but here it's light. That's because this is a vaporizing spray, meaning the ambient temperature is around 800 Kelvin or maybe higher than that. So let's say greater than 800 Kelvin. The reason why you do this type of studies is, well, you measure all the critical information that you want. And then you take this experimental data, and use it to validate your simulation results. This is called as the process of validation, because if your CFD simulations needs to be accurate, they need to capture all the trends that you see in real experiments, correct? That is why people take this type of data. If you're interested in this type of data, you need to refer to Sandia. So Sandia National Lab, N stands for National and L for Lab, is a research institute in the US. And they have a program called as the Engine Combustion Network, and part of which they are conducting and collecting really high quality data about sprays. And the reason why they're doing this is to support computational fluid dynamic research that is being done all over the world on this topic.